Hello everyone, today we are doing 6H, which is addition of ordinates. Now we've already actually done an exercise like this where we're simply adding or subtracting two functions, but today what we're going to do is we're going to do it in regards to circular functions. So today we are learning about addition of ordinates of circular functions, and what you need to be able to do is add the key point of the two graphs and then draw a line through these added key points to form some sort of a function. So we have one example for today, example 12, using the same scale and axes, sketch the graphs of y1 and y2. Thankfully, they've already done that because that's not the point of the exercise, but what we are going to now do is use addition of ordinates to sketch the graph of 3 sine x plus 2 cos 2x. Now, if you remember earlier on in the year when we did this, we looked at 3 key points that we need to start off with. It doesn't really matter what order you do these in, but I would always suggest that you look at intersection points, because here the y values of both of the functions are the same. So it's really helpful because all you need to do is double. You will just need to double the value. You should also look at intercepts because at this point, one function has a y value of 0, which means that the new function is going to be the same value as whatever the other function is that is not 0. And I'll demonstrate that in a sec. And the last thing you should look at are maximums and minimums, so we can also understand what the graph will look like at its maximum and minimum values. Alright, so we're going to go ahead now and look at these. So we'll start off with the intersection points. As we've already spoken about, all we're doing is we're doubling the values. So if we zoom into this function here, what we can see is that we have a few intersection points. There's 1, 2. That's it actually, there's our 2 points. Now we're really lucky because we actually have a scale. We can read this off. We can see that it's about 1.2 maybe, about 1.2. And now if both of those y values there were 1.2, then we would have 1.2 plus 1.2 would be equal to 2.4. So what that would indicate is that the new function is going to be about there. Now of course, we don't always have the luxury of having that scale, which is why when we would have looked at this earlier, it's about just looking at the distance. If I need double of that distance, well, this much plus that much again will lead us directly to this point. So it's not about needing to specifically find that y value. Instead, what we can do is we can just sort of use logic to be able to put it together. Now, this intersection point is actually the exact same value, so we can once again put it at 2.4. And that's the only intersection points that we can find. So that's the first point finished. The next one that we'll do are intercepts. So this is our first intercept here. We can see that the y value of this function is 0 and the y value of this function is 2. So 0 plus 2 is going to give me 2. And what you'll notice is that at every intersection point, this is going to be the case. At every intercept point, not just intersection. So here is 0 plus, and it doesn't really matter what that value is. I know I can read it's 2.2, but it's going to be the value of that red graph because the blue graph in this case is 0. So now what we're going to do is going to go through everywhere that we see any graph equaling 0. So here is 0, then that means 0 plus whatever this value is going to be that value. Next intercept I can see is here, so 0 for the red graph plus 2 for the blue graph, going to end up on the blue graph. The next intercept is over here, so we're adding these two y values together, it's going to end up being here. The next intercept is here, same idea, it'll be the exact same point in fact. And we also have at 2 pi, so that'll be over there. So you can start to see I've got a bit of an outline in terms of what's happening for each of my values. Now the last one we're going to look at are the maximum minimums, and that's going to help me figure out what the graph is going to look like. So we can see that we've got a maximum here, but this one's quite straightforward because that's just 0 plus the maximum. The next turning point that we have is at this x value, and it's really convenient actually that they're both, there's a maximum and a minimum at this point. So if we were to think about it logically, well, not logically, but like mathematically, we can add the values together and then we'll talk about how it would look in a logical sense. I'm just going to move this out the way so that we can focus on the maximums. Now, in terms of mathematically, I can see that this value here is 3 and this value here is negative 2. So what do I end up with? 3 plus negative 2 is going to give me positive 1. So in fact, the new graph is going to have the point there. But as we spoke about before, what we were thinking about, if we don't need to look at the values, we can say, all right, this has that much distance and this has this much distance. But this is negative, which means I am going to subtract that amount away. So starting here, and I'm going to subtract the amount of the blue. You'll see that I end up at the same point. If that doesn't quite make a lot of sense in terms of addition of ordinates, don't stress too much, but it's just that not all the time you're going to have a scale. Sometimes you are just going to have to use a bit of logic. I want that much taken away from the red graph, leads me to this point here. Now for the rest of them, I will just use our values since we already have them there. This is a maximum, but it is also an intercept, so we don't have to worry about that. Here is the next point where we have two maximum values. So here, the red graph, the value is -3, and for the blue graph, the value is -2. So -3 minus another 2 is going to be -5, so that point is going to be there. Finally, our last maximum is over here, but once again, we already have the point. And from there, we now should have enough points to be able to draw a line through it all. So I'm just going to carefully join the dots, just a small exercise. There we go. And it'll probably do something like that. Okay, and there you go. There is your sketched graph.